Hello and welcome to a new video of my Let's Code series. Yay! It's been a while since I made the last video. Yeah, it just takes a long time to plan these videos ahead and edit those, so I cannot do it more often. And today we are doing something very novel, something which I do not have any experience. We're gonna code with Bevy, the popular Rust game engine that's been floating about in my comment section. Yeah, I just thought, why not give it a try, see what the hype is all about. Programming games with Rust sounds amazing, right? So, what we want to do today is Asteroids. Those who don't know what Asteroids is, we are in control of that spaceship in the middle, the triangle, and we can rotate our ship and then accelerate our ship and fire bullets. And what we need to do is avoid those asteroids, because if we crash into it, we'll die, basically. And we can shoot bullets that will destroy the asteroids. The asteroids will split up into smaller asteroids. And okay, they are like alien invaders or something. But the gist is we have to avoid the asteroids and destroy the asteroids with our bullets. That's the gist. And yeah, and I don't think we'll be implementing the alien invaders today. We will only be implementing asteroids and the spaceship. So as you can see, I already have all the Bevy tutorials and stuff open. I must say, the official book, there's an official Bevy book, is really, really sparse. I mean, it only gets into the ECS topic, and there's nothing about how to render stuff and how to make a 2D polygon or make a 3D mesh. I don't know. That is all not explained. And yeah, this I find a little bit sad. Like you can't only rely on the book to just do a simple Hello World project, like a video game project. This is a little bit unfortunate, so we have to also look at the examples. I've been reading the documentation and the examples for quite some time, but I don't know if I'm able to do it on my own, to be honest, because this is all a black box to me. I think this will be even harder than the usual Let's Code videos that I make. Okay, as always, let's create a new cargo project. Cargo init. Do I actually want a binary package? Actually, I probably want a binary package. Okay, let's do that again. Bin. Okay. Wonderful. Hello world. Does it work? Let's cargo run this. Hello world, it works. Rust works, yay. Okay, let's add Bevy. So there are some default features and non-default features. Okay, and let's just look at the... Yeah, this is an example how to render a 2D object, a mesh. And I think I'm just gonna copy this. Let's just copy that. Like Bevy has an app and we can add plugins. We just use the default plugins, and there's a startup system that sets up all of our entities. In our case, we would set up our spaceship and our asteroids. So I think this time we'll do the opposite of what we were doing in the previous video. So we will be doing the UI rendering part first, because I think that's the main hurdle for me, since I don't know Bevy and stuff. And then afterwards we will take care of the game logic. We have a startup system set up. which I think needs commands and meshes and materials. Okay. Oops. Okay, let's just copy this code. We need a camera, of course. We're doing a 2D game. It's a 2D camera. Okay, let's run this so we know Bevy works. Oh, of course, it needs to be. We need to compile the first time, which will take a long time. Okay, it does work, yeah. If I resize the window, it will not resize the content, which is a little bit weird, but okay. Okay, it recognized my GPU. So this is supposed to be our spaceship. So instead of getting a rectangle shape, let's see what other shapes it has. Regular polygon, circle. Okay, we will use circles for the asteroids. That's something we can do. Let's try the regular polygon. Yeah, I need a radius and sides. Wait, the rectangle shape? Oh, we just had default. What the heck is a default value for quad? Vector 1. What is 1? It's just 1. Okay. Okay. So, hold on. How about regular polygon and default? What is the default value of regular polygon? Radius 0.5 and size 6 sides. Okay. So it's a hexagon. What other colors are there? I guess we can define our own color, RGBA. Okay. There is a function for that. Let's make it, I don't know, red. Let's make it red. 1, 0, 0, 1. Recompilation. Let's see how long this takes. Fairly long. Okay, our spaceship should be a triangle, so let's new. Right, new function, radius is 0.5, and then do like 3 as a triangle. Oh, Rust doesn't understand point something syntax. Okay, I didn't know that. I have to say the recompilation time, it's not good. So let's make it 0.1 maybe? Oh wait, we do have a transform in here. We're scaling it 128. We have 0.5 and we're scaling it, I don't know, let's say 50. Okay, that's much more reasonable. The problem is this is a regular polygon. It's an equilateral triangle. So for the player, it's very hard to see where the bullet will be coming from. Like if you look at the example, this one, you can see that the spaceship is quite narrow. So the player already knows where the bullet will be coming from, namely from the pointy end of the spaceship. So a regular polygon won't cut it, I think, which means we need to do something else. Okay, but here's an example on how to create a triangle. So we'll be copying this code. Create triangle. Mesh is a triangle list, and we will insert the triangles. Okay. So this is probably XYZ, and since we are only using the 2D plane, we can ignore the Z component, I think. That's how you interpret this. We will have to import some things. Okay, so instead of doing this, we can just say create triangle. Okay, not sure I completely understand what is going on here. But let's see how this triangle looks like. Okay, we can't see anything. Mesh is missing requested attribute, vertex normal. Okay, I have no idea what this means. How about I look at the implementation of the regular polygon? Maybe I can see. From regular polygon to mesh, we have positions and normals. Normals, okay, we can just say, yeah, point to the Z direction. That's the normal for the 2D plane. So I'm just gonna add this, right? That should work. Normals is what exactly? A vector of arrays. 23 of them. For each side's position, we push something to position and we will push a normal. And normal is always 0, 0, 1. Okay, let's try this. Let's try this again. Create triangle. Nope. Mesh is missing requested attribute, vertex UV. UV, I have no idea what that is. Okay, UVs. UV0. Texture coordinates for the vertex. Do I need to care about this? Let's look at the rectangle. I think that's more easy. Here we go. From quad to mesh. UV is what exactly? Vertices eta map. The third component, this one. U left is 1, 0. So UV needs an array with 2 elements. Okay. Let's do it. UV0. And we need 3. And there's only 2 elements. Now what goes in there is the question. Let's leave it at this. I think it's fine, because we don't have a texture anyway, right? We're just coloring it. Okay, there are no errors, but I don't see anything either. So maybe this is wrong. So let me draw this. I think it's easier if I just draw this. So we have X and Y, and we want to have something like this, right? I want this to be at 0.5, and this is minus 0.5. So if this length is equal to this length, then this is minus 0.25. And this is 0.25. So our first point would be 0.5, which I have here. Our second point would be minus 0.25, 0. No, not 0. Minus 0.5 is the y coordinate. And the third one is 0.25 and minus 0.5. Our sprite would look like that. So at the very top we have 0.5, 0, 0. At the left we have 0 and 1. At the right we have 1 and 1. I think that should be correct. Yay! It's working. Okay, nice. Let's call this create starship mesh. So this is going to be our starship, and then we want to create some asteroids as well. So for the asteroids, we'll be just using some rectangles, I think. Sorry, circles, not rectangles. So instead of this, we will be mesh from shape circle, new, radius is 0.5. The default value is what exactly? 0.5. So let's just do default and let's make it bigger, and they should be bigger than the starship, and color them. I don't know, what do asteroids look like? Color them gray, I suppose. So let's do 0.8. Okay, now this is completely overshadowing our spaceship. We need to also, with translation, translate somewhere else. Like 3. Let's say to the top right, so add 60 and 60. Not sure whether translation comes before the scaling or afterwards. That will make a difference. It seems like this translation came before, right? Our starship is like 50 big, so 60 is a little bit... It's very close to the starship. Okay, let's add more asteroids. How about 10? So we do want to randomize the position, the translation here. So I'm gonna add rand. Oops. Add rand. So we just random and the float type. Random. I think type inference will do the correct thing. And I will get a number between 0 and 1. 1 exclusive, which means I need to scale it. Times 2 minus 1. And then multiply it by... I don't know, how big is the window? Let's hardcode 600 for now. Oh, of course we need to be using floats all the way. But now, cannot infer type for type parameter. Okay, yeah, we need a F32. Oh god, it needs to compile everything again. Just because I added rand? Really? Okay, we've got asteroids all over the place. Nice, but I really need to look up how to get the viewport size. Bevy, get viewport size. Seems like I can get the window size like this and then set resolution. No real idea what this will do, but let's just copy the code from Stack Overflow. It's always correct. Said no one ever. I don't want to check this on every game loop, but we need to, right? It's a little bit crazy, but okay. Window set resolution needs a float. Okay. I don't know what set resolution does, to be honest. Let's not print the window size. Why would I ever do that? Set resolution, not sure about this one. Request the OS to resize the window such the client area matches the specified width and height. Well, obviously this did not work. I could still resize the window, right? Maybe we can do it at startup, in setup. Like at the very beginning, get the window and then resize to this size. And then we just assume the game runs on that size. Yeah? let's not listen to the resize events for now. I just want to get going. Okay, so now we know the window is always this size. Let's create some constants, shall we? Viewport width. Why is it a float? Let's make it a U size. Const viewport height 720. Viewport height and width. Okay, now we just need to multiply this by the viewport width and this by viewport height as a float. With this, all 10 asteroids should be visible within the viewport. Okay, this is obviously not going well. I think... Oh! Okay, I need to halve it because... Yeah, I need to halve it. Right. Here we go. Finally! 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Beautiful. I feel like 10 asteroids is a little bit too much. How many asteroids do we have here? 1, 2, 3, 4. Yeah, 10 is a little bit too much, huh? Let's just make 4. I don't know, 6. Final number 6. Okay, let's move on. Okay, I think I got everything rendered, so let's start on the game logic, shall we? First of all, we need a component for everything to move, right? Now let me look up how to create a component in the first place. Do I want to create a component for the position, actually? I guess so. Let's create a component for the position. Like our starship has a position, so let's insert position. Let's make it a little bit better by making it a tuple, so we don't need to write that much. And here we will insert also some positions. The position is supposed to be these values. Let's remove this line. I think we should synchronize our position with the transform using a system. Yeah, add system, update position, or I don't know, update positions. We will have to query the positions and the transforms. How do I do that? Wow, this documentation is really, really sparse, huh? Query is a query, and I want position, but also transform. And transform has to be mutable. Oh, the query also needs to be mut then. Okay. So we can just iterate over query. In mut query, we have a position and mut transform. Transform translation. I can just change the translation like this. Okay. Let's change it to... Wait, is this a tuple or an array? It's a vec3. So position dot 0, position dot 1, and 0. This should update the positions. Yeah, the positions are updated correspondingly. Nice. I want a marker component for our starship. insert starship. Actually, I do want to change the order a little bit. So let's spawn and then insert bundle, and we can put insert bundle at the very end. Yeah. Spawn and insert bundle. And we will have a marker component for our asteroids. And now we will create a component for velocity. It is also a direction. Hold on, why should I use vec2 instead of two floats? I do think this makes more sense. Vec2 new. And then we have position X, position Y, position 0.x and position 0.y. Now asteroids should have a field called size. Let's make an enum asteroid size. So let's just create an enum. I think there are 3 asteroid sizes. Like looking at this sample implementation, these are the big ones. If I shoot them, they will turn into 2 smaller. Whoa! 2 smaller ones. And they in turn will also turn into more smaller ones. So big, medium, small. And in the beginning, size is always big. Let's create a system to update the transform scale according to our size. So update positions, mode query. We actually need asteroid now. And then mode transform. For asteroid, mode transform in mode query, do transform.scale equals to match asteroid.size. So big would be, okay, we need a vec3 splat. So big would be 100. And then, I don't know, maybe, oh, wait, what is this error? Oh, update asteroid size. I feel like this is not correct. Let's call it update asteroid scale transform or something. Update, translate transform. Add the system to our game loop. I'm not sure about values. How about 80 and then 60? Let's remove this. I can even remove this because default, it's a default anyway. Alright. Okay. Now let's come to velocity. So our starship would have an initial velocity of 0. Can I just use splat? Yeah. Look at me using all the APIs. Okay. And let's define asteroid velocity. let's make it, I don't know. Like, at what FPS is our game rendering? I don't know. I also don't know that. Bevy goes ham and renders hundreds of frames per second. There's not really a mechanism for controlling the graphical frame rate, so no one has a solution for that. Okay, let's make it 1. We can always adjust later. Now insert velocity. Let's just try something out. How about 1, 1, and then normalize, and then multiply with asteroid velocity. I feel like the naming is still weird. Let's call it sync, because we are trying to keep the transform and our components consistent. And now we will add an actual update position. Yeah. Mod query, we will have to mutate position, reading from velocity. For velocity mod position in mod query, we will position.0 equals or plus equals velocity.0. As simple as that. And add the system to our loop. So we will first update position and then sync the translate transform. Maybe we should also say that explicitly. Okay, nice. The asteroids are moving. Oh yeah, all the asteroids have vanished from view, which is also a problem. Smaller asteroids are faster. Let's care about this later, I think. Okay, first of all, we want to fix the velocity, because I want it to be randomized. Okay, let's just create a new function called getRandomPoint, which will get me a vec2, which will just do this. Actually, I can just copy this code. And then we can, for our velocities, we can just get a random point, normalize it, and multiply by asteroid velocity. So this should randomize the direction the asteroids are flying off. Okay, that looks amazing. Oh, what the heck was that? We should make it so that the asteroids always stay on top of the starship, maybe? Can I fiddle around with the Z value? Why don't I keep the Z value for the sync? And we will add the transform back here again with translation, vec3 new 0 0 1. This should make the asteroid stay on top of the starship. Not that it matters, because it's game over when an asteroid gets in contact with our starship. I feel like we should introduce some more constants, like viewport max x, for example, should be height divided by 2. Sorry, width divided by 2. And min x should be minus viewport max x. And then we have a max y and min y, which is the height divided by 2. Let's increase our asteroid velocity as well. Okay. in the asteroid game, the game lives on a particular kind of topology. If you pay attention, like all the asteroids that go off screen, for example, the one on top, will appear back at the bottom, and all the asteroids that goes to the right will reappear on the left side. So this means the game space is actually on a torus. Not that it matters too much, but the gist of it is the top and the bottom are connected. The left and right are connected. So using this knowledge, we can say let new position equals position plus velocity. And we just set it to the new position. But if new position dot x is greater than viewport max x, then we will mutate new position. New position dot x minus equals viewport width, something like that. And else if new position dot x smaller viewport min x, we will add the whole width to it, and the same for y. Okay, this should then wrap around. Okay, this is kind of wrong. Wait, why is this x? Wait. This has to be y, of course. And this is y, and this is, of course, the height. Okay, this looks much better. We do get this sudden disappearing and reappearing on the other side. So that's bad. Let's try to fix that. For that, I think I also need a immutable reference to the transform. Just to look at the size, the scale. Let scale equals transform dot scale dot, let's just choose the maximum of all three. Can I do that? Horizontal maximum of self, yes. Okay, then I would check if new position x is greater than viewport max plus scale or smaller than viewport min x minus scale. Right. And the same for the y component. X should be viewport min x minus scale, and this should be viewport max x plus scale, and same here. Here we go. This should be now correct. Okay. And I think we should divide by half. Perfect! Now whenever it leaves the screen, it should be like move in right again. Let's rename this to half scale, just so there's no confusion. Okay, now let's add the bullet system, shall we? For this purpose, we will add a new component called bullet, a mark component. And we will have to listen to keyboard inputs, which I don't know how to do. But there should be an explanation in the Bevy cheatbook, the unofficial Bevy cheatbook. Input handling, keyboard, checking key state or keyboard events. We can use the keyboard input events. Do want to listen to keyboard events. Event reader. Let's put the imports at the very beginning. Keyboard input. Let's add this to our system. Okay, it works. We are only interested in a pressed state, I think, so let's do that. If that button state pressed equals f.state, we will do something. Is there something wrong? Oh, only one equals sign. Let's read up on the documentation of keyboard input. We have a key code. Key code is an enum. Okay. Event.keycode. I prefer event. So let's name it event. And we will check if it is pressed, and the key code is keycode space. Oh, it's an option, so it has to be some space. When would keycode be none? I don't know. And whenever we press that, we want to add a new entity to the system. So we need to have the commands for the world. So whenever space is pressed, we will spawn a new entity. Commands.spawn, namely a bullet, and we will insert velocity. Let's just do something like this. And oh, you know what? We forgot. We probably want to take control of the rotation of the starship. Let's add a rotation field to our starship, which is a vec2. Starship rotation vec2. New. The starship should face north, so x would be 0 and y should be 1. So we need to sync starship rotation transform, and the query would be looking for the starship and transform, mutating transform for starship mut transform. In mut query, we will transform dot rotation equals, what is rotation? A quad? A quaternion, okay. Interesting. A quad. Is there any convenient methods? Okay, from rotation around the z-axis, right? From rotation z. Angle. Okay, we would need to calculate the angle from the starship.rotation. Can I angle between? Returns the angle between self and right hand side. The input vectors do not need to be unit length, however they must be non-zero. So I would like to compare to 0, 1, of course. Okay, rotation is a little bit confusing, so let's rename this to direction. This makes more sense. So this returns an angle, which we put in here. And we would need to add this. Add our system. Yeah, is that okay? Let's try it out. Okay, yeah, we're not doing anything, so we have to add something. In our keyboard events, we also need to listen to the arrow keys. We need to check the key state. So let's add this. If keys pressed, right? I want to check that. And we would want to check for an arrow left. Else if keys pressed, key code right. And then we will have to rotate it. Okay, I think it's better, it's easier to not put a direction in Starship, but actually a rotation angle. Rotation angle is 0 at the very beginning. And then we will sync our rotation transform by putting the rotation, setting the Z rotation to starship.rotation angle. Yes. Now we need to have a Starship rotation speed, which I will put to, I don't know, 1 at first. And then I will say, I will need to have a query. What query? Mutating Starship. Okay. For mod Starship in query, mod query. Starship dot. Why does it not work? Why is Starship an empty tuple? Oh, wait. Something like this, right? Yeah, okay. Starship dot rotation angle minus equals ship rotation speed. Oh, this has to be mutable. Okay, let's see if our ship rotation works. Oh, goodness! What is happening? Okay, yeah, it works, but this is way too much. Okay, also the controls are inverted, so I have to fix that. So we want to add when pressing left and subtract when pressing right. Okay. The problem is I don't know our FPS, like assuming the angle is in radians, which means let's use 2 pi. Is there a pi constant? 2 pi divided by 360. So this means one frame would rotate 1 degree. Okay, this is way too slow. Okay. Okay, let's multiply by 5, maybe. We'll have to test it and to adjust it, I suppose. But this is working beautifully. Now we can implement the bullet thing. We need a bullet velocity. It has to be, I don't know, I think it has to be bigger than the asteroid velocity. Let's look at this. Oh yeah, much faster than the asteroids. Okay, so let's make it, I don't know, 10? How much faster? 6? 3 times faster? Let's try this out first. So we would then multiply by bullet velocity in the end after normalizing. But how to get the direction though? That's a good question. Let us think on this. So we have our starship. Like this is our direction. So the angle would be this then, right? This way is positive. So we only have the angle, which I'll call theta, and we want to calculate this arrow, basically, this vector. So basically, we just want a point on the unit circle, but starting at the very top. So I guess we just need to add like 1/4 of pi to our angle, so we get the radian for this angle. And then the x-coordinate is simply the cosine of this value, and the y-coordinate is just the sine of this value. Okay, let's just try this out. So we have an angle which is inside Starship. Okay, let's make Starship available here. Okay, Starship.rotation angle plus pi 4th, and then we want to calculate the sine and cosine. Let xy equals sine cosine. Wait, hold on. So it has to be yx. And we will do this. Okay, and we also have to render the bullets, so let's insert the bundle, a mesh bundle. It's a circled, alright. Oh yeah, we need a position actually. Position. Let's put it at the Starship's location. Can I do that somehow? Of course, I need to have a tuple, right? Position. Wait, what is meshes? Oh no, I also need to get meshes and materials. Goodness. It's gonna be a big system. With scale, let's make it 1 pixel big. And let's make it red. Let's see if this worked. Nope. I don't see anything. Well, that's a shame. Let's make the bullet bigger, like 5. Oh, okay, now I can see it. And they're going like the opposite way for some reason. Yeah. Oh god, the bullets, they don't stop. I need to expire them somehow and delete them from the world, otherwise the game will be overloaded with all those bullets. No. Okay, let's make the bullets white because I can't see the bullets. This makes no sense. Oh wait, I added pi 4th. Of course I didn't mean pi 4th, no. It has to be 2 pi 4th, of course. Oh jeez. That's why I'd rather use tau. You know, tau equals 2 pi. It just makes much more sense. So, divided by 2. That should do it. Okay. This is also completely wrong. Oh, I'm changing x and y here again. Okay, no. X is x and y is y. Okay, no need to change it again. Okay, that was the problem, I think. Beautiful. Okay, yes. Okay, let's hide the bullet behind the Starship with translation 0, 0, half. Oh. Yeah, I need a vec 3. Okay, wow, that was a that was a journey. Okay, now I need to expire the bullets For bullet, then let's add a start vector. Start would be the starship position .0. And then we will need to remove bullets from the world. So let's have another system. Remove bullet. I suppose we need to have commands. We need to query, I think. Mut bullet. No, I want the... Wait, do I need a mut? Mutable bullet? Maybe I should read on how to remove entities. Let's look at the breakout example. Check for collisions. We have a mut commands. If there's a collision, we just say commands.entity collider entity, which comes from the collider query, which has an entity. So we want to take control of an entity, and we want to check the position, the current position, and the bullet, right? So we would then, for entity bullet position in query, if let's introduce a new constant, bullet distance. Let's say, I don't know, viewport height divided by 2 divided by 3, that's the bullet distance. And then we will just say if bullet start, wait, bullet? Unknown. Oh, I need to iterate over the reference. Okay, bullet dot start minus position, position dot 0 dot, or the length, greater than the bullet distance, then we will despawn it. Commands entity dot despawn. Query does not need to be mutable. We need to add this as a system. Now, can I make this look better? Okay, the bullets disappear now. That's great. The bullet distance, let's make it go farther away. Okay, yes. It works. Okay. Now we need the starship to accelerate. So in the keyboard events... Oh god, I have too many functions here. Keyboard events, we would also need to mutate velocity. If keys pressed, key code up, then we should do something with our velocity. We need to introduce starship acceleration. F32. I don't know. Let's make it 2. Just for testing purposes, we need to adjust later on. Oh, and we need to decelerate. So let's also check for down. So velocity dot 0. Normalize this times velocity 0 dot length plus starship acceleration, and the same for deceleration. And we need to be careful. I mean, the velocity could be zero, a zero vector, so this is bad. So let's normalize our zero, right? If it is zero, then it's zero. And we should be careful not to have a negative deceleration or something like that. That is also bad. I think we want the maximum of that and zero, actually. And there should be a maximum acceleration as well. Max velocity, actually. Wait, can we have a negative velocity? Let me check. No, we cannot. And we also cannot decelerate. What am I talking about? There's no deceleration. Okay. There's no deceleration. So let's remove the code again. No deceleration. We can only accelerate. And it will like stop by itself because of air resistance. There's no air resistance in space, but I mean, okay, I guess space resistance or something. Okay. Max velocity should be, I don't know, let's say 10. Is there a max velocity? Can I like accelerate? I think there is a max velocity. I think I broke this game. My starship won't die anymore. So let's add the minimum of this and the starship max velocity. Okay, let's see if our acceleration works. Nope. Nope, it does not work. Because velocity is always zero. And this will be zero. Oh damn, okay. Wait, what am I doing? We need to preserve velocity dot zero. We can only add on the velocity. That's how acceleration works. Which means if the starship has already speed in one direction and I change the direction and accelerate in another direction, this won't cancel out the initial direction, right? So I cannot just replace velocity zero. I always need to add something to it. And what do I add to it? I need to add the direction to it. Direction of the starship. Okay. Let's implement something on starship. Let's call it get direction. And we will return a vec2. Get a self-reference. And we already implemented this logic in the bullet thing. Here we go. Let's just steal that and create a new vector, this time in the correct order. Now I just need to do starship dot get direction. Beautiful. And here we also need to get starship dot get direction multiplied by starship acceleration. And then we need to get the maximum velocity, right? Make sure that the velocity does not exceed the maximum velocity. So if velocity.0.length, if it exceeds the starship max velocity, we will have to do something. Namely, normalize it, or 0, times starship max velocity. Here we go. Oh, whoa, okay, wow. hold on, that's way too fast. That's way too fast, okay. Let's put acceleration, I don't know, at 1? No way, right? Oh, get direction is not normalized, right? No, wait, it should be. It should be normalized at 1. It's a sine and cosine. But maybe my frames per second rate is just simply too high. That could be. Okay, let's see if I can cancel out the acceleration. Yes, I can. Lovely. And I just need to... Wow, this is way too fast still. I just need to create some space resistance. Let's call it Starship deceleration. Let's add a new system for that. Let's call it decelerate Starship. My systems are all over the place. Okay. Query is a query. We want a mode of velocity with Starship. For mode velocity, no, for velocity in mode query, we will decelerate. 0 equals velocity dot 0 times equals, does it work? 1 minus Starship deceleration. Cannot borrow query is mutable. Yeah, it is not declared as mutable. Velocity, okay, I need to declare this as mutable as well, okay. Yeah, this will always work, right? Let's just try this out. Okay, wow, what the heck? This is now super slow. Maybe we should decelerate only if this is not pressed, which would make sense. So only decelerate when we are not accelerating. Let's add a comment. Only decelerate when not accelerating. Okay, we're accelerating and then decelerating. Holy crap, we are decelerating so fast. Our acceleration is also fast. So I think deceleration needs to be much slower than the acceleration. Much, much slower. And let's make acceleration also slower. Okay, whoa, yes! Now this is replicating the feel of Asteroids, yes! I love it! I love it! Wait, why are the bullets a little bit... The bullets are weird. Okay, the bullet distance is too short, I think. This needs to be fixed. Let's divide by 1.5. Or multiply by 1.8. Something like that. Okay, I think what's now missing is the collision detection. First of all, we want to detect collision between asteroids and the starship. So detect starship asteroid collision. Hold on. What we need is position. Actually, we want entity. Because after the collision, we want to remove the starship. So entity position and with starship. And we need asteroids. So with asteroid, we also need a position. Asteroids query. Starship query. For entity position in starship query, starship position, starship entity, and then we will loop over all asteroids. Asteroids, asteroid position. Oh, no tuple needed in asteroids query. I do need the asteroid size. So let's also access asteroid. Since I need the asteroid size, actually I can just read from transform, right? How about I read from transform with asteroid? So let's read from transform. Asteroid transform. And we will also read from starship transform. Starship size would be starship transform dot scale dot max element, and asteroid size would be asteroid transform dot scale max element. And we just assume that the starship is a circle. That makes collision detection much easier. Otherwise, we need to do some serious maths. So let's just assume starship is a circle with the scale, following scale is radius. Scale divided by 2 is radius. We just need the position or the distance. Distance is equal starship position minus asteroid position dot 0 dot length. Okay, so if distance is smaller than starship size half plus asteroid size half, then we have a collision. And we will need to despawn the starship by using commands. Commands.entity starship entity dot despawn. Okay. Okay, I just need to bump into, yes, I've despawned. Nice. Okay, to make it a little bit lenient, because our starship is not really a circle, to say that our starship is a circle is a little bit overstated, right? The player would die if an asteroid is just near the starship, and it doesn't seem fair. So let's make it actually, let's make the collision area of the starship smaller. Let's divide the radius by 2 again. So starship size divided by 4. The player won't rage quit. Okay, now for the other sort of detection. Detect bullet asteroids collision. We need to despawn the bullets, so we also need the commands. Bullets query is querying the bullets. We need entity, also transform, position with bullet. And we have asteroids query. We need transform and position, right? And actually we also want to despawn it, potentially. For bullet entity, bullet transform, bullet position in bullets query. We'll also loop over all the asteroid entity, asteroid transform, asteroid position in asteroids query. And we'll do the same collision check again. This time they are both circles, so it's alright. Bullet instead of starship. So this time we're divided by 2 only, and if there's a collision, we would despawn the bullet entity, and we'll also despawn the asteroid entity. Okay. Actually, I want asteroid. I want to look at the asteroid itself. So now we have to spawn 2 more asteroids, 2 more smaller asteroids. So let asteroid new size equal, we'll match asteroid.size. So for big, the new size would be asteroid size medium. And for medium, the new size would be small. And for small, we will not respawn any asteroids. Okay. If let asteroid new size, sum asteroid new size equals asteroid new size, we will spawn new asteroids. Okay, let me copy the code where we spawn the asteroids in the first place. We will copy the code here. We will only spawn 2 new ones. Size would be asteroid new size. Insert position. Position would be at the asteroid position. Velocity, we just pick a random direction again. Oh, we need meshes and materials. Okay, fine. Let's just get the meshes and materials. Where is it? Here we go. There's a problem here. What? Use of moved value. Oh, moved here in previous iteration of loop. Okay, yeah, we can make the enum a copy type. Oh, clone copy. Okay, yeah, we have some duplicated code here, but for our purposes, this should suffice. Whoa, okay, okay. Nice, okay. Cool. Oh, I'm dead. This is so fun. Okay. We need to change the sizes, asteroid sizes. Let's import asteroid size. Get scale, I guess. self. Currently we have hard-coded it, right? Asteroid scale transform. Okay. To make this more idiomatic Rust, let's rename this to scale and rename this to direction. All right. And yeah, we need to adjust the sizes. That's a little bit too big. How about 30? And what's in the middle of 130? That would be 65. Ooh, okay. This is so fun! Oh my god, I'm so proud of myself. Holy moly, what? Oh, damn. Okay, there's no new game button. Jeez. Okay, but I think let's just code until this point. Let's call it a day. It's nearly midnight here, as you can see on my system clock. I am very, very satisfied with my implementation of Asteroids. Oh wait, we have some some errors, but warnings. Could not despawn entity because it doesn't exist in this world. Do we need to care about this? I mean, it didn't crash, so I'm happy about this. No idea. Okay, yeah, I think that is it for this Let's Code. As you can see, there are lots of improvements to make here, like better graphics for once, and especially, you know, a new game button. Maybe a implementation of 3 lives would be great. Better collision detection, more accurate collision detection, more importantly. That would be nice. What else? Yeah, like, I had a lot of fun coding with Bevy. I have to say, it is really fun using the ECS system and whatnot. And the fact that it is in Rust is really nice. And I would use it again 100%. Unfortunately, Bevy is still in the, you know, experimentation phase, whatever that means. That means probably there will be a lot of breaking API changes, as we also saw in previous versions. Right. So not sure if I want to fully invest in Bevy just yet, but it is really fun to program with, I have to say. And I do think there are lots of undiscovered features, like features that I have not discovered yet in Bevy that do exist, but is documented nowhere, I could imagine. So Bevy needs to do better with their documentation, to be honest. Because the info in their official documentation is practically non-existent. You really need to dive into the examples and whatnot to find out how to do things at all. For example, the camera thing or the rendering, this is not documented at all. Which is crazy to me. How did Bevy get such a big community if they don't document anything? Oh, I can see if you look in the middle of the screen, whenever I get a bullet, the bullet will first appear in the center of the screen. That is a bug. That needs to be fixed. I will let you guys fix it as an exercise, I guess. Okay, that said, I think it's time to finally finish this video. It has been so long. This video has been so long. Yeah. And I assume editing will be even longer. So if you like this video, please like and subscribe as always. With that, I'm gonna sign off. Hope to see you next time, maybe. Write me in the comments what I should code next, either with Bevy or with something else. Yeah. Then have a nice weekend, everyone, and bye!